Your AI application is processing 500,000 requests every day. The LLM bill is too high. How would you reduce the cost without hurting the quality? So, very good interview question. A lot of AI engineers are actually facing this interview question. Now, let's understand why this interview question is very important and what is the interview actually trying to ask you, right? So, what is the interview trying to get from you? Okay, so it's not really about LLMs, right? Whether you know LLMs or everything, it's about how you think under a constraint. So it is giving you a scenario and saying this is the scenario, and then you tell me how you would resolve this. So very good question. Now, some of the engineers might quickly jump in and say, you know what, I'm going to go ahead and use a cheaper model, right? Whatever the models that I have, I'll go to and use a cheaper model. So cheaper models means less cost and your bill will automatically come down. Okay, so this is partly true, it's not entirely true, and it is honestly a very weak answer, right? So because let's understand this, right, that maybe the model that they are already using is cheaper and still it's basically resulting to huge bills, right? There could be reason because maybe the size of your prompt is very high, you have a very prompts that are very huge, so you are basically sending so much of prompts to the model. So even if it is cost like less than a cent, because you multiply it maybe by million, it is going to explode your cost, right? So the other thing could be like, number of times you're calling the model, right? So you may be calling the model like a million times, right? And then obviously each call will cost you some money, right? And there might be a case where you are actually calling the model for something which you have already completed. So there is a task that is already done by the model, but then you are going up and your script is going and calling the same model. So these are some of the things that could actually cause your model to be called unnecessarily, and obviously you would basically end up with higher cost, right? So before we you actually give a answer like cheap model, you need to actually understand all this concept. So now what we are going to do here is, like, instead of just telling you theoretically, I'm going to show you a small demo. So what we're going to do is we're going to simulate a demo. So basically imagine that there is a chatbot and there are like so many customers that are actually using this chatbot. So what they do is they ask a question and they get a response, right. So here what we have here is like so we just trying to simulate it. So these are basically the sample questions. Now here we just have like 5 to 6 questions because we don't want to spin up like 500,000 questions and end up costing a lot of money, but we are going to simulate this, right? So we have two things. One is the expensive model. So again, expensive model per each call will cost you $0.5, and this is just for reference. Okay, this is just to show you like the how using a cheap model or expensive model will be, and there are other factors as well which I'm going to cover all of this here. Okay, so then there is a cheap model which costs you this much. Okay, now these are basically the sample questions that we are going to chart. I mean, these are sample questions which you're going to ask the model. So look at this model questions, right? What is your refund policy? Now see this exact same question, I'm asking it here, I'm asking it here, right? Because different users, right? Like I might ask the same question, what is the refund policy? Some other user might also ask the same question, right? So that is possible, correct? So now these things we are going to send it to the model. Okay, so first let me just go ahead and run this model. So I'm going to run this model. So as it runs, so what I'm going to show you here is there are particular two functions. So one is run naive. So what this does is it will basically go through. Okay, just give a second. I need to go to this folder. All right, so let me just run it. Okay, so while that is running, so there is this function run naive, right? So what it does is like it will basically go through the entire sample request. So like you can see here all the sample requests, each question, right? So each question, what it does is it will basically call the model. So here it will take this question, it will send it to the model, it will take this question, it will send it to model, it will take this question, it will send. So likewise it will send all the 5 or 6 questions, it will send to the model, right? You are making a call per each of the question, right? and it is actually using the expensive model. Okay, so each question it will send to the model, it will use the expensive model, and it basically tracking the costs here. Okay, then there is something called as optimized version. So what we are doing is like, when you send a question to the model, right, you get the response, we cache it. Okay, and then what happens is when you go through this, like for example, if this is a question, it will send it to the model, it will get the response and it will cache it. All right, when this question goes, because it's the same question, we already have the answer in the cache. So instead of sending that question to the LLM model, what we do is we take the answer from the cache itself, because it will not cost us money, right? Just a memory, right? So though that is an additional thing that we are doing. And on top of it, what we are also doing is basically we are calling a cheap model. All right, so there are two things we are doing. What we are doing is, one is basically we are caching the response so that duplicate requests will not go to the model. So we are avoiding unnecessary duplicate questions that is been going to the model, and again, because we already have the answer, we are taking it from the cache. And second thing, we are using a cheap model. And then what we have is we basically compare, we basically create a chart and compare how this will be like, we multiply with a scaling factor saying like, okay, 5 requests this much, but maybe 100,000 requests, this is what the cost would be. So it's good for us to understand. Okay, so this is now already in, so let me just go back and right, so these are the things, right? So when I run the naive expensive version, so this part of the code will get executed. This part of the code will get executed. Now this is like, it is basically going and calling the model for each of the question. Okay, so now you can see here like, what is the refund policy? So 73 tokens it call, and this is a cost. How do refunds work? This is a cost. What is the refund policy? So see, this question is already sent, but again, we what we are doing is we are sending the same question again, because maybe some other user is sending the question, and then obviously you'll get some other tokens and a similar cost, right? So overall, for the 5 requests, we encountered this many costs, and for 500,000 requests, $18,300. This is the projected cost. Now, if I run the optimized version, so now with the optimized version, so what we are doing is we are running this. So one, we are using the cheap model. Second thing, what we are doing is we are using a cache. So if a request is already, if a question is already answered, we are not asking the same question again. We are taking from the cache. So now you will see the difference here. So you can see here, what is the refund policy? So because we are using a cheap model, we would basically get this response. Now, how do refunds work? Again, cheap model we getting. Now look at this, what is your refund policy, right? So we have $0, right? Because it skipped, we are not sending it to the model, right? We skipped this. So similarly, we skipped this. So you can see here we have skipped this too. So imagine like, if you are sending this question like 500,000 times, right? So 500,000 times if you're sending the question, all you have to do is you have to send this, you have to call the model only once. Remaining 499,000 whatever it is, like, we don't have to send it, we can take it from the cache. That way it is actually saving the money. So even if you use the expensive model here, because we are skipping these questions, it will still save you a lot of money. All right, so if you look at this projected, this is like $4.26 only. And then if I run the cost comparison, you can see here, like, if you are using a expensive model with no cache, it is taking you to $18,300, while the caching and the optimized model will only cost you $4, right? So you see the big difference, right? So even if you basically use the expensive model here, still the cost will be very less, because we are skipping these things, because we are caching it, right? So these are the two things that you can actually use to kind of get the cost down. Now this is a very good answer for us to actually give, but before we talk about there are a few other things, but before we talk about those things, right, so let's basically understand like why this actually happens. See, why this problem happens in the first place. See, what happens is, right, when we start writing the system, when we start writing the code, right, what we do is we always look for expensive model, because expensive model means they have better reasoning capabilities and everything, and we are very confident that you actually give us accurate results, right, or near accurate results. So it's not always accurate result, near accurate result. So you are very comfortable with the expensive model. Okay, so what happens is like, okay, at the beginning it's all about whether we are getting the right answers or not, whether the system is working properly. So you'll use a expensive model. Now everything will work fine. Initially when it will be like, you will have very less queries, right? So you have less queries, so your cost is like, in a way it is very minimum, right? So now this is where the mistake happens, right? So when you are, let's say, 100 requests, right, you people don't go and kind of check like, okay, how do I when I scale this, how much money I'm going to spill. That is something, the cost metrics is something that people don't usually put. So this is very important. Understand this, right? So your model may be working today with certain things, but you always need to do a projection of your cost. So if you do not do, what happens is at some point it will explode, and then you come back and you need to do all these things. Okay, and then you come back and say like, oh, I'm gonna change everything to the cheaper model and everything, and I'll cache it everything. But again, that's that's another common thing that people do, mistake that people do is they'll just go back and make changes, and they say, I'm going to switch everything to a cheaper model. Now this is a very important thing. So what happens is, like, some models, like even if you shift from the higher models to the cheaper model, it will work. But there are some models, some use cases which require a very strong model. So if you switch to the cheaper model, what will happen? Your quality will come down, right? So that's where the problem happens. Okay, you need to first evaluate what is the right model for the right use case, and then only you switch it. And second thing is related to the cache that we did. So what happens is, like, cache, like for example, in our use case, what we did is we cached it. So let's say we cached it based on the question. So it say, what is your refund policy? And if it is an exact duplicate, we are caching it. But user may also ask questions like this: how do refunds work? So in the current example, right, so what happens is, these two questions are treated as differently, but in context these are actually same. So you need to actually use a system where it's not just the exact sentence. The agent will basically go and identify, like, it's also semantic version saying like, okay, these two are actually the same question, so we can give the same answer. So that optimization should also be done. Okay, and always, right, always have a metrics in place, cost metrics, performance metrics. So every time, like, once you have deployed to the production, you need to monitor this metrics and see like if there is any deviation, right? If there is deviation, you have to come back before it explodes. Okay, all right. So you can basically give this answer and it's going to be good. But additionally, right, apart from these two answers, you can also give us some more explanation. So that will basically help you a lot better. So one is basically prompt compression. Okay. So if you are sending lot of prompts, right, so a lot of instructions which is not really required, then it will also obviously that will convert into tokens, and it will basically cost you money. So trimming unnecessary instructions or repeated boiler code of every single call, that will basically save you a lot of time and also a lot of money. Okay, so prompt compression is something that you can take a look at it. Sometimes batching also helps. So basically, if there are a lot of smaller requests, right, so you can combine the smaller requests into one large request and you can call it. So that way, your response time, also your cost will get reduced, because you're just making one call, right? So, and the other thing what you can do is like a context. So you can limit the context. So when I say limit the context, limiting the unnecessary context. So this is very, very important. It's not like, you just limit the entire context as a whole, but limiting unnecessary context. Think of AI coding assistant, right? So if let's say I have this one, right, I have a repo right now, I have just one folder. Imagine I have 10 folders. If my AI assistant is basically scanning all the 10 folders, then it will increase the context. I may be asking a particular question that might be available in just one particular folder. So instead, what I'll basically give an instruction saying that, hey, you know what, whatever that I'm asking, you can just search this particular folder instead of scanning the entire. So that way your context size is limited, so it will basically reduce in tokens and it will reduce the cost. So that is another thing. Also you can cap the output length, right? So when usually, like when you give a prompt, you get lot of response from the AI model, like so lot of output. So again, those outputs will cost you some output tokens, right? So what you can ask AI is like, do I really need all this output, right? So you can basically cap this and say like, oh, I just need like 1,000 tokens or maybe 100 tokens depending upon the use case, right? You can cap that as well, right? And finally, one important thing is this routing logic. So we talked about giving the using the cheaper model, right? But then again, the part is like, if this is a complex task, you cannot use a cheaper model. So you need to have a heavier model, right? And if it is a relatively easier task, then you have a cheaper model. So what we need to do is we need to put a routing logic saying that, hey, whatever the request that is coming up, is the request simple? If the request is simple, take a cheaper model. If the request is complex, then you use a heavier model. So that way you're using a cheaper model for simple tasks, you're using a heavier model for complex tasks, so that one, you are reducing the costs. Two, you're also making sure that your quality is not dropped. So this way you can actually reduce the cost. So these are all the things that you can say for the interview, so that uh, any question related to this, like you can cover all of these things. All right. So yeah, that's it. I hope this was helpful, and if it has helped you in your interview question, I'm very happy. Please do share it across, and I'll see you guys in my next session.